All right, let's talk about function and not a function. So the definition of a function is that for every input, there is exactly one output. So input is X and output is Y. So if you choose an X, there should only be one answer for that X. So here, following the rule for vertical line test. So the vertical line test is not sponsored by Post-it. So vertical line test means that if I were to draw a straight line up and down anywhere on this graph, would I hit this graphed line twice? There's nowhere that I can make a line where I would hit this graph twice, which means it passes the vertical line test. So this is what a function looks like when it's graphed. It could also be a straight line like this. As long as it passes that rule, it is a function. Now this one here does not pass that rule. I can easily choose a place. Okay, that was a horrible line here, but trust me here. There we go. So I have made a line and it's hit the graph line twice, which means this X has two answers. That's not allowed. Okay, not only is it happening there, it's happening in multiple spots. Multiple spots. If it happens once, it's not a function. If it happens once, it's not a function. So this is happening multiple times. All right, let's shift down here. Okay, so what does it look like when it's as ordered pairs? So 3 has one answer, 5. 2 has one answer, 7. 1 has one answer, 9. Now, if I were to do this, 2, 3, that would no longer be a function because 2 now has two different answers. That's not allowed. Okay? For this one, now, for some reason, people get confused and think that if this is doubled, that's fine. That's not fine. I mean, they think it's not fine. They think it makes it not a function. This is totally a function. I know that 8 is repeated twice, but it's the answer. Two different numbers can have the same answer. What the problem would be is if one number had two answers. That's not allowed. So if I do this, it is no longer a function because 5 has two answers. That is not allowed. Okay? Now, we're going to try to do some f of x exercises. Now, this is function notation. It's written as f of x equals 2x plus 9. But what if I wanted to know f of 3? Now, if you noticed, I did change something. I changed something from an x into a 3. And they're telling you, hey, I want you to change everything that's an x into a 3 and then solve it. So we're going to write, instead of 2x, we're going to write 2, 3 plus 9. So now you just solve it. 2 times 3, that's going to be 6 plus 9. That's going to make 15. So f of 3 equals 15. Now the next one we'll do is this one here. So this says f of 2 plus 4. So I have to figure out what f of 2 is first. And then when I'm done, I'm going to add 4 to it. So I'm going to go to the original f of x, okay, which is this one. F of x equals 2x plus 9. So I'm going to write f of 2 equals 2 times 2 plus 9. 2 times 2, that's going to make 4 plus 9. That's going to make 13. So I know that f of 2 is 13, which means I can replace f of 2 with 13. So now instead of writing f of 2, I'm going to write 13 plus 4 equals 17. Now let's shift down here and do f of 4 times 3. So we have to figure out what f of 4 is first, and then when we are done, we're going to multiply it by 3. So let's look over here. 2x plus 9, we're going to change x into 4. So f of 4 is 2 times 4 plus 9. That's going to be 8 plus 9. That's going to be 17. F of 4 is 17. So now that I know 17 is f of 4, I can replace f of 4 with 17. So now this is going to be written as 3 times 17. 3 times 17 is going to be 30 plus 21. The answer is 51. Okay? All right, good. Now let's go to the next thing that we're going to talk about, and that is linear or nonlinear. Okay? Linear and nonlinear. So how do you know by just looking at an equation if it is linear or nonlinear? Now, the rule is what's allowed to happen to x is x is allowed to be multiplied with, it's allowed to be added, it's allowed to be subtracted, and it's allowed to be divided. So I could add minus 19 and then divide by 5, and this would still be a linear function. Even though I'm doing all 4, that's totally allowed. Or we can just do 2 of them, okay? As long as you're doing these things, or you could do nothing. You could literally just write y equals x, and that would still make a straight line. So these are linear. What's not allowed is you're not allowed to have an exponent, you're not allowed to have a radical, and you're not allowed to have the x at the bottom of a fraction. So it's not allowed to be in the denominator. So here, x is being multiplied by 8 and divided by 5. That's completely fine. So this makes a linear function, or a linear graph. Okay, what about this one? This one's being squared. Immediately, this is not going to make something linear. Okay, what about this one over here? It has a radical and an x. It has 2 wrong things. This still is going to not make something linear. It's going to make non-linear. This is non-linear, this is non-linear, this is linear, and this is linear. Why? Because this one has a radical, already going to make a curved line. And the x is down here, also going to cause a curved line. Squared is going to cause a curved line. So those are the obvious things that would point out if something is linear or non-linear. Now let's do 2 problems with simple interest. So the first one is you have $500 in the bank, 3% simple interest for 4 years. What's your total at the end? Okay, so let's see how much he's made in 4 years. So 500 times 3, that's going to give me 1,500. But now, when you're dealing with a percent, you have to move this decimal point over twice, causing it to be 15. So every single year, this person receives 3% of their $500. So 3% of $500 is $15. So they're going to get $15 every year. And this is happening for 4 years. 4 years have passed. How much money did they have in their account? So 15 times 4, that's going to make 60. Okay? So they made $60. They started with 500. So their total is now $560. So if I asked you how much they made, you would say $60. But if I asked you how much was the total, you would say $560. All right, now let's do this one. Okay, I know. Let's figure out how much they're going to make. I don't know how long they've been saving. I just know how much they have as total and what the percent is. But we can still find out how much they're making every single year. So 600 times 4, okay, that's going to make 2,400. Now we have to move the decimal point over twice because we're turning the percent back into a whole number. So now this number is 24. This person makes $24 every single year. Every single year. So I know that they started with 600. So if I take away 600 from this, I'm left with $76. Okay? I'm left with $76. So 24 plus 24 is going to be 48. That's not enough. 48 plus 24, that's going to leave me with 72. That's still not enough. Now, I should have written 72 here, I'll be honest with you. I think I messed up. So this should be 72, 72. All good. So this should be 72. So it took 1, 2, 3 24s to get to 72. So how many years have they been saving? 3 years. And that's it. Sorry about the error.